Hello, this is Leroy Meadows, and in this session, we are going to work some exercises dealing with activity-based costing and some of the concepts we learned in the chapter. So let's go ahead and take a look at our first exercise. Dade Metals manufactures patio furniture. The company budgets overhead costs of $400,000 for the year. It also budgets 20,000 machine hours and 5,000 direct labor hours. So we're given two things. The first thing we need to do is compute the plant-wide overhead rate, assuming the company allocates overhead based on A, machine hours, and then B, direct labor hours. So we're given two different allocation bases here. So we want to find out the overhead rate by using each base. So the first one is plant-wide overhead rate using machine hours. So in this situation, we're going to take our estimated overhead, $400,000 for the year, and divide it by the budgeted number of machine hours. So if I take $400,000 divided by 20,000 machine hours, that's going to get me a plant-wide overhead rate of $20 per machine hour. So let's just put $20 in here. Then we have to compute it using the plant-wide overhead rate using direct labor hours. So I'm going to take that 400,000 and divide that by the number of labor hours we're expected to use. And in this case, we have 5,000 direct labor hours. So we'll divide that. And then for the plant-wide overhead rate using direct labor hours is $80. And just a point here, real quick, our allocation base, how we're spreading out our overhead, it is important to have the allocation base be as precise as possible. As you can see, there is a big difference between using machine hours and direct labor hours. So let's take a look at the next thing we need to do. Job 121 uses 100 machine hours and 50 direct labor hours. Allocate overhead to job 121, assuming overhead is allocated based on A, machine hours, using the answer from part 1 and part 1A, and then B, direct labor hours, using the answer from part 1B. So using the total amount of overhead we're going to apply using machine hours is going to be $20 per hour for overhead times the number of machine hours we use for the job, which is what, 100 machine hours. And so my overhead allocated for 2A using machine hours is $2,000. And then let's look at B, direct labor hours. So our overhead rate for direct labor hours, using direct labor hours, is $80 per direct labor hour times the number of direct labor hours we used for the job, which was 50. And that should give us an answer of $4,000. Oops. There we go. Now, here, and let's just say that it took $100 of materials and or $1,000 of materials, $1,000 of labor. So, and let's just say this is what we're looking at here. And so using using machine hours and then using direct labor as our allocation base. Okay. So let's say that our materials and labor were $1,000. So under each method, of allocating overhead, our materials and direct labor costs are going to be the same. So now let's overhead allocated using machine hours, 2,000, and then 4,000 using the direct labor hours. How much is the cost of the job for each method of allocating overhead or applying overhead? Well, in this situation here, I've came up with if machine hours is our allocation base, then our total job cost is going to be $4,000. However, if we use direct labor hours as our allocation base, our job cost is going to be $6,000. So as you can see here, there's a big difference between these two. This should be an illustration that we want to choose our allocation base carefully. And the reason being is if we overcost something, let's say that this is more accurate of a cost we would assume. If we're basing on machine hours, then we could be overcosting the job by $2,000 because this is going to be $2,000 higher than here. So this is just an illustration of whenever we do choose to allocate overhead based on machine hours or direct labor hours using a plant-wide rate, we want to be careful in how we choose our allocation base because that can make a big difference in our pricing and product mix decisions. Okay, so let's go to the next exercise here. And this is going to be a little bit, it's going to have a little bit more to it. So we're going to go ahead and take a look at this. Texture produces parts for a machine manufacturer. Parts go through two departments, molding and trimming. The company budgets overhead cost of $240,000 in the molding department and $200,000 in the trimming department. The company budgets 16,000 machine hours in molding and 25,000 direct labor hours in trimming. The actual production information follows. And this right here, as you see I'm moving it, this is the amount of the actual usage here in the two departments. First of all, we're asked to compute a departmental overhead rate for the molding department based on machine hours and a departmental overhead rate for the trimming department based on direct labor hours. Okay, so let's take a look here and let's get our calculator out. And let's see here. Let's see, company budgets overhead costs at $240,000. So $240,000. And we're going to divide that by the number of machine hours we expect to use, which is what, 16,000 for the molding department. So 16,000. And we get an overhead application rate of $15 per machine hour in the molding department. Now let's look at the departmental overhead rate for the trimming department. And how much overhead do we expect to have in the trimming department? 200,000 shows us right here. Divided by, in the allocation basis, 25,000 direct labor hours. And in the trimming department, we get an overhead application rate of $8 per direct labor hour. Okay. So those are our two departmental overhead rates. Then it tells us to determine the overhead cost per unit for each part using the departmental rates. Okay, so we know what our departmental rates are. Now let's take a look at our actual data here. The molding department, and we're given two parts, part Z and part X. So let's look at part Z first. Let's see. It will be, let's see, molding department. Each unit takes 2.0 machine hours, so 2.0 machine hours in the molding. And let me, oops, I do want to go there. 2.0 machine hours, and the overhead department in the molding department is $15. Okay, so how much overhead is going to be allocated to part Z from the molding department? Well, if we have $15 per machine hour plus times 2 machine hours required to make part Z, we're going to have overhead allocated of $30. Now let's take a look at the trimming department for part Z. Part Z goes in the trimming department, and it will take what? Let's see, 3 direct labor hours per unit. Let's see, so 3.0 per unit. And the overhead application rate is what? We figured out it was $8. So we're applying $8 of overhead for each direct labor hour. And Part Z requires 3 direct labor hours. So how much overhead are we going to apply from the trimming department? $24. 4 activities in the trimming department. And now we've calculated our overhead for both the molding department and the trimming department. And so what is our total overhead we're applying to part Z? We are applying what? 30 plus 24 is going to be $54. Now let's take a look at part X. Part X requires what? Let's see, 2.5 machine hours and 4 direct labor hours. And let's just put that in here. Okay. So now, part X requires 2.5 machine hours in the molding department to be made, and we're applying overhead rate of $15 per machine hour. So 15 times 2.5 is what? 37.5, so $37.50. And then in the trimming department, we have 4 direct labor hours per unit, and the amount of overhead being applied per direct labor hour is $8. So $8 per direct labor hour times 4 direct labor hours being used to make part X, and that is going to be $32. So what is the total overhead applied to part X? Well, $37.50 plus $32 should be $69.50. So this is an illustration where we apply based on departmental rates, but this is also a good time to point out that we choose multiple allocation bases for departmental overhead from one department to the next. And why would that be? Because the consumption of resources are different between both parts, but the type of cost driver that's being used in each department is different. In the molding department, we are heavily machine operating. In the trimming department, we are doing a lot more labor intensive work. So the more labor intensive work we have, we typically want to go with direct labor hours or direct labor costs. And then for molding, and with things that are heavy on machine usage and not as much labor usage, we want to use probably something else. In this case, molding department, we would use machine hours. So here's an illustration of using departmental rates, but then each department figuring out what the cost driver is in that department, and then using the appropriate allocation base for overhead in their respective departments. Okay, our next exercise here. A manufacturer reports 3 activities: assembling components into products, product design, and sales order processing. Determine whether each of the following cost drivers relates to assembly, design, or order processing. So we're looking at these for the cost drivers here, and we want to see what activity they could be used or what type of allocation base, what kind of cost driver, what kind of activity that these cost drivers could be applicable to. So let's take a look at the first one here. Number of sales orders processed. So what type of activity could that be used for? Assembling components, product design, or sales order processing? Well, number of sales order processed wouldn't be really applicable to assembling products or product design. So we would probably use that for sales order processing here. So, and now you can see what the cost driver is, and we're picking out the appropriate activity where that cost driver could be used as a appropriate application basis. Number two, direct labor hours to assemble components. Okay, would that be assembly, product design, or sales order processing? Well, that would direct labor hours to assemble components would probably be more applicable to assembly than anything else. So assembly, because using direct labor hours to assemble components wouldn't be really applicable to design because design is not assembling the order, and it really wouldn't be applicable to order processing because of the fact that an order, orders can vary in different sizes and everything. So processing things, tying it to order processing is probably not appropriate. What about the number of design changes? What activity could that be linked to? Assembly, design, or order processing? Well, the more appropriate one in this case would probably be design, uh, because design costs are definitely tied to how many design changes we make. What about the number of components assembled? Number 4 here. Number of components assembled. Well, that would probably be, it gives us a clue here, number of components assembled. So that would be more appropriate as a measuring or a cost driver of assembly. What about the number of design hours? Well, again, you don't incur design hours unless you're designing a change. So or designing a new product. So that would be an appropriate cost driver for design activity. And then finally, the number of shipments made. Well, assembly and design definitely don't seem like they'd be an appropriate activity to relate to the number of shipments made. But order processing, that would be a more appropriate activity where we would use the number of shipments made as our cost driver. So um, order processing. So, and this is just a backwards flip on a lot of times you'll be asked in different exercises, through different situations. You'll be given the activity and have to choose a cost driver that's more appropriate for that activity. Here, we just had the cost driver and we tried to link it up to the activity that would be most appropriate to. So, okay, let's take a look at our next exercise, exercise 17-15. And we got a little bit of work here though, but now we're getting into the actual activity-based costing. We've seen some other stuff. There are previous exercises, the first two exercises. We're using a plant-wide overhead rate, depending on different types of allocation base we could use. Then we looked at departmental rates in the second exercise, and then the previous exercise about linking the cost driver with the respective activity. Now we have where we're going to actually apply the overhead activity. And we're going to go through and work on the activity-based costing for overhead. Now, Lucerne Company reports the following for its overhead costs for the year. And we have 3 activities here: engineering support, electricity, and setup. We have the budgeted overhead costs associated with each activity. So we have our 3 cost pools here. Cost pool for engineering support has overhead costs of $24,500. This cost pool for electricity has overhead associated with it of $34,000. And then the setup activity has overhead costs associated with it of $52,500. And then we also have the cost driver, the budgeted activity usage. What are we basing our overhead rates on for each activity? Well, engineering support is going to be based on the number of design changes. Electricity is going to be based on the number of machine hours. And then finally, setup is going to be based on the number of setups. So the first thing we're asked to do is compute the activity rate for each activity using activity-based costing. Okay, so we're going to complete each activity, the computation for an activity rate for each of the 3 activities here. So let's take a look at my engineering support. What are my budgeted costs for engineering support? We have it right here, $24,500. And I expect to have 70 design changes, so it's going to be tied to 70. So let me get these. Okay. So how much am I going to have per design change? I'm going to spread this 24,500 out over the number of design changes. That's my cost driver. So 24,500 divided by 70. And for each design change, I'm going to allocate $350 worth of overhead. And let's get that. Okay, now let's look at electricity. How much overhead do I expect to have with electricity the next year? $34,000. And that's going to be based on how much? 3,400 machine hours. So divide that 34,000 divided by 3,400, and that should be what, $10? Oops. Yep, $10. Okay. And what is our setup overhead cost? $52,000. And that's based on the number of setups we complete. So how many total setups am I going to have between all my different products? So I'm going to have $350 or 350 setups between all my different products. So I'm going to take my 52,000, divide that by 350 setups. And so for every setup that we complete, we're going to assign $148.51. Okay, I wonder why I got a weird odd number here. My setup amount is 52,500. And we'll divide that by 350. There we go. A little bit better, $150. So for each time I do a setup, I'm going to assign $150 of overhead. So now we want to the company's pro model used these activities to produce 1,200 units during the year. 2 design changes, 140 machine hours, and 12 setups. Allocate the overhead cost to the pro model and compute its overhead cost per unit using activity-based costing. Okay, so we are going to take our activity rates here, and let's go ahead and just copy our activity rates here. Engineering support was what? 70 hours or 70 design changes. Electricity No, I'm sorry. Let's go back here. I want the activity rate. Sorry. And that was $350. And let's format this here. My activity rate was $350 for engineering support. Electricity was what? $10. And then $150 for setup activities. Okay. So let's go look at our engineering support. How much, let's see, it was based on design changes. So how many design changes did I have associated with the Pro model? Well, it tells us here we had 2 design changes right here. So I had 2 design changes, and each design change incurred $350 of overhead. So 2 times 350 is going to be $700. Now let's take a look at the electricity activities for the Pro model. Again, for every machine hour, we assign $10 of overhead to the machine to the Pro model. So $10 per machine hour. How many machine hours did we use in making the Pro model? It tells us here we had 140 machine hours. So I'll take my 140 machine hours and multiply that by the rate of $10 per machine hour. Oops. And that's going to get us what? If I multiply that out, $1,400. Now let's take a look at our setups. We incurred 12 setups, and for the 12 setups, we incurred overhead rate of $150 for each setup. So that gives me how much? Should be what? $1,800? 12 times 150. Okay. So we're told to allocate overhead to the Pro model and compute this overhead cost per unit using activity-based costing. Okay, so how do we get from all these numbers here to a per unit? Well, first of all, I'm going to add up the amount of overhead, the total amount of overhead applied to the Pro model from all the different activities. I'm going to add those all up. So I have 700 plus 1,400 plus 1,800, and that should give me $3,900 of overhead to be allocated here, just for making the Pro model. Now, the total allocation cost for making all the Pro models is $3,900. Now, I'm going to spread that out evenly over the number of units I produce, or the number of Pro models I produce. And how many units did I produce during the year? It tells me I produced 1,200. So I'm going to spread that $3,900 over 1,200 units, and I get an overhead cost per unit of $3.25. So that is my overhead cost per unit. So what did I do here? I figured out the activity rate for each activity based on total design changes, total machine hours, and total setups. And then I computed the allocated overhead cost for each activity based on our particular product that we're measuring, the cost that we're measuring, in this case, the Pro model. I calculated the total overhead we're going to allocate and apply for the Pro model based on our activity rates and times of usage. Gives me my total allocated costs all together for making the Pro model. And then on a per unit basis, I'm going to take my total allocated cost of overhead, spread that out evenly or divide that by the number of units produced to get an overhead cost per unit. So when I go to make my individual pricing and product mix decisions, this is what I want, because I know how much direct labor I'm going to have. I know how much in direct materials I'm going to have. So there, so now I have this for my allocated overhead. Then I'm going to be able to come up with a total cost and then make my pricing decisions based on that. So, okay, this is Leroy Meadows. That concludes this session. Have a good day.